All right, this video is going to go over just some basics of implicit differentiation to make sure that you understand how to do this process. So an implicit curve means that we can't necessarily solve it for y, so we need a way to take the derivative. Keep in mind that y is a function of x, and so when we take the derivative with respect to x of functions of x, that's great. But when we take the derivatives of functions of y, we have to use the notation that then you need to take the derivative of y with respect to x. It's basically a chain rule type expansion here. So we'll rewrite the equation after that so that all of the dy dx terms are on the left-hand side. We'll factor that out and then we'll solve. So let's jump into a problem here so I can explain this to you. All right, so I have x cubed times, there's a multiplication between these, sine of y plus y equals 4x plus 3. So the derivative of that first piece, x cubed times sine y, I need to use product rule there. So derivative of the first times the second plus the first. Now the derivative of sine y, notice up here, is cosine of y, and then I need to multiply that by y prime, or multiply that by the derivative of y with respect to x. Now the derivative of just this y piece is y prime, or dy dx. And then the derivative of the right-hand side is 4x plus, nope, it is just 4. All right, so now we want to keep everything with a dy dx on the left-hand side and move whatever does not have a dy dx over to the other side. That way I can solve this. So I'm going to keep x cubed cosine y dy dx plus dy dx here. And I'm going to have 4 minus 3x squared sine of y. I can then factor out a dy dx on that left-hand side. And I get that dy dx then must be equal to that right-hand side over what we factored. Oh my goodness, there should be a plus 1 here. Plus 1. Dy dx, when I factor out of this and this, I need a plus 1 here. Okay, so that's going to be my final answer for my derivative. Let's look at another one. Now, they don't all have trigonometry in them, but these examples that I pulled did. So let's find the derivative of this function. Now, derivatives of functions that just have x's in them keep the same format that we did before. Like none of that changes. So the derivative of 4x to the 5th is 20x to the 4th. The derivative of tangent of y is secant squared of y times, I need to take the derivative of that y function with respect to x. The derivative of y squared, I'm going to take the derivative just like I would as if it was an x. So I'm going to say is 2y. And then I need to take the derivative of y with respect to x. And then the derivative of 5x is just 5. Everything with a dy dx gets moved to the left-hand side. Everything without a dy dx gets moved to the right-hand side. Okay, let's factor correctly this time, shall we? So dy dx, secant squared y minus 2y. And so I can then just divide this by that factor term to get my final answer. There.